Hello everyone and welcome back to our channel. Today we start operating systems, one of the highest yield topics in IBPS SO. We will cover two topics today, OS fundamentals and CPU scheduling. What is an operating system? An operating system is the core system software program that manages computers' hardware resources and also it provides a platform for running application programs. It acts as a bridge between you, that is the user, and the computer physical components like CPU, RAM, or hard drive. Without an operating system, you would have to write the code directly in machine language just to display a simple text on screen or even press a key on keyboard. Core functions of operating system. First is process management, deciding which program gets CPU time and when. See, the CPU is the brain of the computer, but it can only focus on one micro task at a time. The operating system acts as a controller, switching between tasks so fast that it feels like everything is running simultaneously. Second, memory management, allocating and tracking RAM usage across programs. RAM is a short term high speed working memory. The OS hands out RAM to programs when they open, keeps them from stepping on each other's toes, and reclaims that memory when they close. Third is file management, organizing and controlling access to files on storage. Your hard drive or SSD is a massive vault. The operating system creates structured systems like folders, directories, so you can save, find, edit, and delete files easily without losing track of where data actually lives physically. Fourth, device management, controlling input output devices via device drivers. Hardware components speak different languages depending on who made them. The operating system uses special software translators, that is, drivers, to allow programs to talk seamlessly to printers, keyboards, mouse, and displays. Last, security and access control, managing user permissions and protecting data. The OS ensures that users only access what they're allowed to. It keeps malicious applications from altering critical system files or spying on other programs. Types of operating systems. First is batch operating system. Jobs are collected into a batch and processed one after another with no direct user interaction during execution. So how does it work? Users submit tasks to an operator. The operator then groups similar jobs together and feed them to the computer to run sequentially. So user does not interact with the job while it's running. Jobs are submitted, queued, and processed sequentially. Example use case, payroll processing, large batch data jobs. Historically, batch operating system is the earliest form of OS and it is best used for high volume, repetitive tasks like generating monthly payrolls or utility bills. Second is time sharing operating system. Allows multiple users to use the same computer system simultaneously. How? By dividing the CPU time into small slices given to each user in rotation. Each user gets the illusion of having the CPU to themselves because switching happens so fast. The OS switches between active tasks in milliseconds. So every user thinks that they have the CPU to themselves, whereas multiple users are using the same computer simultaneously. This is the OS level technique that enables both multitasking and multi user access. What are the examples? Modern desktop, laptop OSs like Windows, Mac, Linux are all time sharing operating system. Third is real time operating system, an operating system where processing must happen within strict guaranteed time limits, also called deadlines. Failing to process on time result in failure. There are two types. First is hard real time. Missing a deadline is a total system failure. There is zero margin for delay. Example, airbag systems. If somebody's car crashes somewhere or gets into an accident, an airbag does not open on time, it might cost somebody's life. So that is why it is an example of hard real time operating system. Missing a deadline is a total system failure. There is zero margin for delay. Soft real time operating system. Missing a deadline degrades performance but isn't catastrophic. Example, video streaming. Fourth is distributed operating system. Manages a group of independent, physically separate computers and makes them appear to the user as a single system. Resources like processing power, storage, data are shared across multiple physical machines, but the end user see it as one unified interface. Example, cloud computing environments. Fifth is network operating system. Runs on a server and manages network resources. Allow computers to communicate, share file, printer over a network. Unlike a distributed OS, each machine retains its own OS and autonomy. The network OS just manages shared network resources. So here, users are aware that multiple independent computers exist. You explicitly know which machine holds which file or program. Example, Windows Server, Novel NetWare. Sixth is mobile operating system, tailored specifically for handheld, battery powered devices like smartphones and tablets. Optimized for touch interfaces, power management, mobile connectivity like Wi Fi, cellular, and sensors like GPS. Examples are Android, iOS. Quick comparison table. First is batch OS. The key idea was jobs processed sequentially and no user interaction during run. Example, payroll processing. Then time sharing OS. CPU time divided among multiple users or tasks. Example, multi-user systems. Real-time operating system. Guaranteed response within a strict deadline. Example, pacemakers, airbags. Distributed OS. Multiple physical computers appear as one system to user. Example, cloud computing. Network OS manages shared resources over a network. Users are aware that multiple independent computers exist. Example, Windows Server. Last, mobile OS tailored for handheld devices. Example, smartphones. Now, some important concepts of operating system. First, multiprogramming. Multiple programs are loaded into memory at the same time. The CPU switches to another program when the current one is waiting to avoid CPU idle time. The goal is to maximize CPU utilization. Only one program executes at any single instant, it just switches rapidly. Historically, the innovation that made third generation computer efficient. Recall video 1, multiprogramming was introduced in generation number 3. Second is multitasking. It is an extension of multiprogramming, but the focus shifts to user experience, giving the illusion that multiple programs are running simultaneously. It uses fast time slicing, that is, small chunks of CPU time given to each task in rotation. So, switching feels instantaneous to the user. So, multitasking is an advanced form of multiprogramming. Instead of waiting for a program to pause, in multiprogramming, the CPU switches to another program whenever the current one is waiting. So, in multitasking, instead of waiting for a program to pause, the OS actively switches between program after a tiny time slice, making them all run concurrently in real time. In short, multiprogramming switches CPU only when a program gets blocked or waits, whereas multitasking switches CPU continuously using time limits, giving the user a smooth experience. That is why you can have a browser, a document, and music playing at once, even on a single core CPU. Remember this difference and the concept of time slicing. Third is time sharing, a specific technique that enables multitasking and multi user systems. CPU time is divided into small slices and distributed among multiple users or tasks in rotation. Essentially, the underlying mechanism that makes multitasking and multi user OS possible. So, what is the difference between multitasking and time sharing? See, multitasking is the goal, that running multiple apps at once, and time sharing is the method, it is the technique used by OS to achieve multitasking by giving each task a tiny fixed slice of CPU time. So, remember the difference. Multitasking is the goal, and time sharing is the method. Fourth, multiprocessing, two or more CPU core actually executing instructions simultaneously. So this one is a genuine parallel execution and not switching. This is fundamentally different from the above three. The above three can happen on a single core through fast switching, but in multiprocessing, genuine parallel execution happens. Master comparison table. First, multiprogramming. The core idea is multiple programs in memory. CPU switches only when one waits to avoid idle time. Is there simultaneous execution? No. It is happening one at a time and switching is happening. Second is multitasking. Core idea is illusion of simultaneous execution for the user via fast switching. The switching is happening within time slice. Is there simultaneous execution? No. It appears simultaneous, but it is not. Difference between multiprogramming and multitasking. In multiprogramming, the CPU switches only when one process waits. In multitasking, the switching happens actively after a tiny time slice, making them all run concurrently in real time. Third, time sharing. It is the technique, the time slicing technique that enables multitasking and multi-user access. Difference between time sharing and multitasking. Time sharing is the technique and multitasking is the goal. Is there simultaneous execution in time sharing? No. Fourth, multiprocessing. Multiple CPU cores genuinely running instructions at once. That is, they are running instructions parallelly. Is there simultaneous execution? Yes, true parallel execution. Process states. A process is simply a program in execution. As a process runs, it moves through different states. The first state is new. The meaning is process is being created. Ready, meaning process is loaded into the memory and it is waiting for CPU time. It is ready to run, just not currently running because it is waiting for CPU time. Third is running. That means process is currently being executed by the CPU. Fourth, waiting or blocked, meaning process is paused, waiting for some event to complete before it can continue. Fifth, terminated, meaning process has finished execution. CPU scheduling algorithm. C. A CPU can only run one process at a time. Therefore, operating system needs a strategy to decide that which process gets to use the CPU and for how long. These strategies are the different CPU scheduling algorithms. Before diving into different types of scheduling algorithm, let us first discuss the important terminologies. First is arrival time, the time at which a process enters the ready queue. Ready queue means process is loaded into memory and it is ready to run, but it is waiting for CPU time. Second is burst time, the total CPU time a process actually requires to complete. Third is completion time, the time at which a process finishes execution. Fourth, turnaround time, total time from arrival to completion, calculated as completion time minus arrival time. Fifth, waiting time, time a process spends waiting in the ready queue. It is calculated as turnaround time minus burst time. Last, response time, time from arrival until the process gets the CPU for the first time. We will also understand these terms with the help of an example. Preemptive versus non-preemptive scheduling. What is preemptive scheduling? The operating system can forcibly pause a running process mid execution and take away the CPU to give it to another process. And non preemptive is once a process gets access to the CPU, it holds on to it until it finishes completely or it voluntarily pauses. What are the examples for preemptive? Round robin, SRTF, which is shortest remaining time first. For non preemptive, FCFS, which is first come first serve, SJF, shortest job first. We'll discuss all these examples in detail. First is FCFS, first come first serve. Processes are executed strictly in the order they arrive, like a queue at a counter. The process that arrives first gets executed first. Simple implementation. FCFS is non preemptive, meaning once a process gets access to the CPU, it will hold on to it until it completely finishes. That means if a process holds the CPU, it will not give CPU to another process until it is completed first. Major drawback: if a long process arrives first, all shorter processes behind it must wait, even though they would finish faster individually. So, for example, job 1 is first in the queue and it will take 2 hours to execute it. Behind it is job 2, job 3, job 4. Every job from 2 to 4 will take only 1 minute to execute. But since job 1 is first in the queue, it will execute first and it will take 2 hours. So behind job 1, 3 jobs with only 1 minute will have to wait for 2 hours. So this is the convoy effect and it happens in first come first serve algorithm. So now let's understand first come first serve algorithm and terminologies both with the help of this example. So there are four processes and their arrival time is 0, 1, 2, 3. In first come first serve, the process that arrives first gets executed first. So first P1 will get executed, then P2, then P3, then P4. Their burst time is also given. What is burst time? Time it will take to get executed. So P1 will take 4, let's assume this is minute. So 4 minutes to get executed. So P1 will run from 0 to 4. Then after completion of P1, P2 will run till 3 minutes. So 4 to 7. Then after completion of P2, P3 will run for another 1 minute. So 7 to 8. Then P4 will run from 8 to 10. Okay, so this is how it will run. So completion time will be P1 has completed at 4th minute, so 4. P2 has completed at 7th minute, so 7. P3 at 8 and P4 at 10. So these are their completion time. Now what will be turnaround time? It is completion time minus arrival time. So completion time for P1 is 4. It arrived at 0th minute. So 4 minus 0 is 4. For P2, it will be 7 minus 1, 6. P3, 8 minus 2, 6. And P4, 10 minus 3, 7. So this is the turnaround time. Then waiting time. What is waiting time? Turnaround time minus burst time. So turnaround time we have already calculated and minus burst time. So these are the respective waiting time for process P1, P2, P3, P4. In non-preemptive scheduling algorithm, waiting time is same as response time. Response time is the time from arrival till it gets CPU for the first time. So waiting time and response time will be same in non-preemptive scheduling algorithm. And FCFS is non-preemptive. I hope this is clear with the help of an example. Second is SJF, shortest job first. The process with the shortest execution time or shortest burst time is selected regardless of arrival order. In FCFS, arrival order matters. In shortest job first, shortest execution time matters. It minimizes average waiting time. The drawback is requires knowing execution time in advance and can cause starvation for longer processes if short ones keep arriving. So, if all the jobs with 1 minute or 2 minute arrives, the CPU will be allocated to those jobs and a job with 60 minute, it will never get the CPU until all the short job finishes. So this is the meaning of starvation, that longer processes will never get the CPU if shorter ones keep arriving. Third is SRTF, shortest remaining time first. By the way, SJF was also non-preemptive. Now, SRTF is the preemptive version of SJF. At every new arrival, the scheduler compares the new process burst time against the remaining time of whatever is currently running and switches if the new one is shorter. So, for example, if a job with 4 minutes is running and it has already ran for 2 minutes. Now 2 minutes is remaining for job 1. But at that time job 2 arrives and its execution time is only 1 minute. So the CPU will see, okay, for job 1 2 minutes is remaining but job 2 has only 1 minute execution time. So it will switch from job 1 to job 2 and job 2 will get executed first and then the remaining of job 1 will get executed. So this is shortest remaining time first. Fourth is round robin. Each process gets a fixed small unit of CPU time called a time quantum in rotation. After its time quantum expires, the process goes back to the end of ready queue and the next one gets a turn. For example, there are three processes P1, P2, P3. P1 takes 4 minutes to execute, P2 5 minutes to execute, and P3 6 minutes to execute. And I have set the time quantum as 2 minutes. So P1 will get executed for 2 minutes, then P2 will get executed for 2 minutes, then P3 will get executed for 2 minutes, then again P1 will get executed for 2 minutes, and it will keep on happening in rotation. Designed specifically for time sharing systems. Fair since every process gets regular turns. Performance is sensitive to the size of time quantum. If the time quantum is too small, excessive switching overhead happens. If it is too large, it will behave like FCFS. Remember, round robin is preemptive CPU scheduling algorithm. Fifth is priority scheduling. Each process is assigned a priority number. The CPU is given to the highest priority process first. Drawback starvation. A low priority process might wait indefinitely if higher priority processes keep arriving, like we saw in short job first. What is the common fix? Aging. Gradually increase the priority of processes that has wait too long to guarantee that they will eventually run. Sixth is multi-level queue scheduling. The ready queue is split into multiple separate queues based on process type. For example, a system process queue, an interactive app queue, a background batch queue. Each queue can use its own scheduling algorithm. For example, system process queue might use round robin, background batch queue might use FCFS. There's also a scheduling policy between the queues, commonly either fixed priority, like system queue always service before batch queue, or time slicing, like round robin, across different queues. Important exam relevant detail. In a standard multi-level queue, a process is permanently assigned to one queue based on its characteristics. It does not move between queues. So once the operating system puts a process into a specific queue based on any traits, it stays in that exact queue for its entire lifetime. It cannot move up or down to a different queue no matter how long it waits or runs. So that was all for this video. If you gain some insight, do give us a like. If you have any queries, please let me know in the comment section. And if you haven't still subscribed the channel, please do it so that you do not miss any upcoming video. Thank you so much. Keep watching Array.